Hello everyone and welcome to my YouTube channel. Today's topic. Today we are going to discuss the long answer questions and multiple choice questions of chapter Gravitation from Lakhmir Singh. Hope you will like this video. So the first question for the day is question number 51, which is define mass of a body. What is the SI unit of mass? Define weight of a body. What is the SI unit of weight? And what is the relation between mass and weight of a body? So this is a very simple question. So first they are asking what is mass of a body. So mass is just the quantity of, it's a thing to measure the quantity of matter, the atoms, the molecules present in something, in an object. It is known as mass, and the SI unit of mass is kg, as we all know. Then weight of a body is the force by which an object is attracted towards the earth. So like weight, we all know weight is equal to mass into gravity. And the second part of the question is what is the relation between mass and weight of a body? So the relation between weight and mass of a body is that the weight of a body is directly proportional to its mass. इसका मतलब कि अगर किसी बॉडी का मास डबल करेंगे हम तो उसका जो वेट है वो भी ऑटोमेटिकली डबल हो जाएगा. मतलब अगर कोई ऑब्जेक्ट है जिसका मास है 2 kgs तो उसका वेट विल बी 20 kgs बिकॉज 2 into 10 इज़ ग्रेविटी. सो अगर हम उसका मास डबल कर देंगे 4 कर देंगे देन उसका वेट विल ऑल्सो बिकम 40 विच इज़ द डबल ऑफ 20. तो अगर हम किसी ऑब्जेक्ट का मास डबल करते हैं तो उसके साथ उसका वेट ऑटोमेटिकली डबल हो जाता है. इट्स डायरेक्टली प्रोपोर्शनल. नाउ द नेक्स्ट क्वेश्चन इज स्टेट द यूनिवर्सल लॉ ऑफ ग्रेविटेशन. नेम द साइंटिस्ट हु गेव दिस लॉ. Define gravitational constant. What are the units of gravitational constant? So the answer for this question is, according to universal law of gravitation, every body in this universe attracts every other body with a force F which is directly proportional to the product of their masses m and inversely proportional to the square of the distance. मीन्स इस लॉ से ये स्टेट होता है कि इस यूनिवर्स में जो भी बॉडी है जिसका मास है वो हर बॉडी एक दूसरे को अट्रैक्ट करती है और वो एक फोर्स अट्रैक्ट करती है और वो फोर्स जितना ज़्यादा उस बॉडी का मास होता है उतनी ज़्यादा उस फोर्स उतना ही ज़्यादा पावरफुल होता है. एंड उनके बीच में जो डिस्टेंस होता है उस पर भी दैट फोर्स वेरीज. अगर डिस्टेंस कम होगा तो फोर्स ज़्यादा होगी और अगर डिस्टेंस ज़्यादा होगा देन फोर्स कम होगी. And this law was given by Sir Isaac Newton, as we all know. And gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square by kg. And the unit for gravitational constant is Newton meter square by kg square. So the next question is, what do you understand by the term acceleration due to the gravity of Earth? What is the usual value of the acceleration due to gravity of Earth? And state the SI unit of acceleration due to gravity. So the first part is the uniform acceleration produced in a freely falling body due to the gravitational force of a Earth is called acceleration due to gravity of Earth. सो अर्थ की ग्रेविटेशनल फोर्स की वजह से किसी फ्रीली फॉलिंग बॉडी में जो ऊपर से गिर रहा है उसमें जो मोशन प्रोड्यूस होता है दैट इज़ एक्सेलरेशन ड्यू टू ग्रेविटी. बिकॉज जब भी कोई ऑब्जेक्ट ऊपर से गिरना स्टार्ट करता है देन उसकी जो इनिशियल वेलोसिटी होती है उससे वो इंक्रीज़ होती है. एंड वो जो एक्सेलरेशन जो उस इंक्रीज इन द स्पीड को कॉज कर रहा है दैट इज़ द एक्सेलरेशन ड्यू टू ग्रेविटी. And the usual value of acceleration due to gravity is 9.8 meter per second square. But we many times take it as 10 meter per second square in round. And the SI unit of acceleration due to gravity is meter per second square. So question number 53 is the acceleration due to gravity of Earth, g, small g, a constant? Discuss. And calculate the acceleration due to gravity on the surface of a satellite having a mass of 7.4 into 10 to the power 22 kgs and a radius of 1.74 into 106 meters. Which satellite do you think it could be? So the solution for the first part is No, the value of acceleration due to gravity is not constant at all the places on the surface of the earth. Since the radius of earth is minimum at the poles and maximum at the equator, the value of g is maximum at the poles and minimum at the equator. As we go up from the surface of the earth, the distance from the center of the earth increases and hence the value of g decreases. The value of g also decreases as we go inside the earth. तो एक्सेलरेशन ड्यू टू ग्रेविटी की जो वैल्यू है ऑन द अर्थ इट्स नॉट एग्जैक्टली कांस्टेंट एवरीवेयर लाइक एज पहले वाले क्वेश्चन में वी सॉ दैट एक्सेलरेशन ड्यू टू ग्रेविटी की जो वैल्यू है दैट डिपेंड्स ऑन द डिस्टेंस बिटवीन द टू ऑब्जेक्ट्स. तो व्हेन वी अर्थ इज़ नॉट एन एग्जैक्टली राउंड, सो जब हम पोल्स पे जाते हैं द रेडियस बिकम्स लेस. नाउ बिकम एज द रेडियस बिकम्स लेस, उसकी वजह से द ग्रेविटेशन acceleration due to gravity increases, but at the equator the radius is very means it's more than that of pole, so the acceleration due to gravity decreases here. And even if we go in, if we are not at the surface of the earth, a bit assume 10 meters above the surface of the earth, then also the gravity will not be same because the distance is increasing from the center of the earth. So question number 53 का B part, it's also very simple, it's a numerical. We have to calculate the gravitational force on the surface of a satellite. Question में हमें satellite का mass and radius given है. So the mass of that satellite is 7.4 into 10 to the power 22 kgs and radius is 1.74 into 10 to the power 6 meters. So to calculate the gravitational force on the surface of that satellite, we will use the formula G m by r square, जिसमें if we put the values it will be 6.7 into 10 to the power minus 11 into 7.4 into 10 to the power 22 divided by 1.74 into 10 to the power 6 का square. Now this is equal to 6.7 into 7.4 divided by 1.74 into 1.74 into 10, which is equal to 1.637 meter per second square. So this will be the acceleration on the surface of that satellite, 1.637 meter per second square. Now question में one more thing is there that what satellite do you think is the gravitational force जो हमने अभी calculate की है किस satellite की है. So when you divide 9.8 by 6 you will get this exact same value 1.637 and 9 point which किस सैटेलाइट की ग्रेविटेशनल फोर्स अर्थ से 1/6 है, वी ऑल नो मून. सो ये जो ग्रेविटेशनल फोर्स वी जस्ट कैलकुलेटेड इट्स ऑफ द सैटेलाइट मून. क्वेश्चन नंबर 54 इज स्टेट एंड एक्सप्लेन केपलर्स लॉ ऑफ प्लैनेटरी मोशन. ड्रॉ डायग्राम्स टू इलस्ट्रेट दीज लॉज. So the solution is Kepler's first law. The planets move in elliptical orbit around the sun, with the sun at one of the two foci of the elliptical orbit. This law means that the orbit of a planet around the sun is an ellipse and not an exact circle. An elliptical path had two foci and the sun is at one of the two foci of the elliptical path. So as in this diagram you all can see the first image, उसमें you can see that the orbit, the path जिस पे the planets rotate around the revolve around the sun, that is not a complete circle because circle का एक fixed बीच में एक center होता है, but an ellipse does not have one center, it has two focus points which are known as two foci and sun is present at its one of the foci. So yeah, the planets not move in a complete circular shaped orbits, it's an ellipse. Now Kepler's second law states that each planet revolves around the sun in such a way that the line joining the planet to the sun sweeps over equal areas in equal interval of time. This means that the planet does not move with constant speed around the sun. The speed is greater when the planet is nearer the sun and less when the planet is farther away from the sun. Kepler's third law states that the cube of the mean distance of a planet from the sun is directly proportional to the square of the time it takes to move around the sun. So the next question, and question number 55, is the mass of a planet is 6 into 10 to the power 24 kgs and its diameter is 12.8 into 10 to the power 3 kilometers. If the value of the gravitational constant be 6.7 into 10 to the power minus 11 Newton meter square by kg square, calculate the value of acceleration due to gravity on the surface of that planet. What planet could this be? Now the next question, question number 55, it is also a very simple question. Just one trick is there, that we have to calculate the gravitational force of a planet जिसका मास हमें गिवन है एंड रेडियस नहीं दिया है, डायमीटर दिया है, दैट टू इन किलोमीटर्स. तो सबसे पहले तो उस डायमीटर को हम किलोमीटर्स से मीटर में विल कन्वर्ट. So that will be 12.8 into 10 to the power 3 kilometers. So it will be 12.8 into 10 to the power 6 meters. And then we will have to find the radius. Radius is half of the diameter. So we will divide the diameter by 2. So we get the radius 6.4 into 10 to the power 6 meters. And now we will put all these values in the formula gm by r square, because again we have to calculate the gravitational force on the surface of a planet. So 6.7 into 10 to the power minus 11 into 6 into 10 to the power 24 divided by 6.4 into 10 to the power 6 का square. Now this is equal to 6.7 into 60 divided by 6.4 into 6.4, which is equal to 9.8 meter per second square. Now we all know that इसका भी second part में it is given that we have to tell that किस planet का this can be the gravitational force. So we all know that 9.8 meter per second is the gravitational force of Earth. So this planet जिसका हमने अभी gravitational force calculate किया है, it can be Earth. Now we will move on to the multiple choice questions. So the first question is, an object is thrown vertically upwards with a velocity of u. The greatest height h to which it will rise before falling back is given by a u by g, b u square by 2g, c u square by g and d u by 2g. सो ये क्वेश्चन ऐसे सॉल्व नहीं होगा एंड इट्स नॉट गिवन इन द बुक ऐसे भी कहीं पे दैट हाँ एच की एक ये फॉर्मूला है, बट हाँ इसको यू कैन सॉल्व बाय द थर्ड इक्वेशन ऑफ मोशन दैट वी स्क्वायर माइनस यू स्क्वायर इज इक्वल टू 2gh. सो उससे यू विल गेट दैट इट इज h इज इक्वल टू यू स्क्वायर बाय 2g. सो द करेक्ट आंसर विल बी b u square by 2g. Question number 57. The mass of moon is about 0.012 times that of the Earth and its diameter is about 0.25 times that of the Earth. The value of g on the moon will be a less than that on the Earth, more than that on the Earth, same as that on the Earth, and about 1/6 of that on the Earth. Now I know बहुत सारे आप लोगों में से D ऑप्शन को करेक्ट मान रहे होंगे, but D is not the correct option. As question में they are asking the value of capital G, which is gravitational constant and it's same everywhere. So it will be same as that of the Earth. But if there would have been a small g, then वो same नहीं होता, then D इसका आंसर होता about 1/6 of that of the Earth. So आपको उसका you have to take it whether it's a small g and a capital G. Now question number 58 is, the value of g on the surface of the moon A is the same as that on the Earth, B is less than that on the Earth, and C is more than that on the Earth, D keeps changing day by day. So इसमें they are asking that the value of small g O in comparison to Earth, what is the value of small g on Moon in comparison to Earth? So answer will be B is less than that on Earth. On the any given day, it will be less than that of Earth because sun का जो mass होता है that is very small in comparison to Earth. Next question, question number 59 is the atmosphere consisting of a large number of gases is held to the earth by A. Winds, B. Clouds, C. Earth's magnetic field, D. Gravity. Now ये तो बहुत ही ज़्यादा सिंपल क्वेश्चन है, इलॉजिकल टाइप्स क्वेश्चन दैट अर्थ के एटमॉस्फेयर में जो भी गैसेज हैं वो अर्थ पे क्यों है, वो उड़ के वो स्पेस में क्यों नहीं जा रही हैं, बिकॉज सो फर्स्ट ऑप्शन इज विंड. तो विंड तो खुद ही इट्स एयर, एयर इज अ कॉम्बिनेशन ऑफ मैनी गैसेज, तो ऑब्वियसली वो तो आंसर हो नहीं सकता. क्लाउड्स, क्लाउड्स दे आर, वो खुद ही हवा में, वो क्या रोकेंगे किसी को. अर्थ्स मैग्नेटिक फील्ड, अब उन गैसेज में आयरन तो है नहीं या फिर एनी सब्सटेंस विच इज मैग्नेटिक जो अर्थ की मैग्नेटिक फील्ड से रुका रहेगा. सो सी इज ऑल्सो द फॉल्स, सो ओनली डी इज लेफ्ट, ग्रेविटी. सो या डी इज द करेक्ट आंसर, ग्रेविटी. Question number 60 is the force of attraction between two unit point masses separated by a unit distance is called A. Gravitational potential, B. Acceleration due to gravity, C. Gravitational field strength, D. Universal gravitational constant. So इसका आंसर will be D. Universal gravitational constant. The weight of an object at the center of the earth of radius r is 0 r times the weight at the surface of the earth infinited 1 by r2 times the weight at the surface of the earth. So its correct answer will be A, 0, because किसी भी चीज़, the gravitational force at the center of the earth is 0. So उसका मास कुछ भी हो, it will be multiplied into 0, and so the weight of any object in the center of the earth will be 0. Question number 62. Two objects of different masses falling freely near the surface of the moon would A. have same velocities at any instant, B. have different accelerations, C. experience forces of same magnitude, D. undergo a change in their inertia. So इसका आंसर will be A. have same velocities at any instant, because उसकी एक्सेलरेशन विल ऑलवेज बी सेम. उस ऑब्जेक्ट के मास वगैरह से कुछ फ़र्क नहीं पड़ता, एज पहले भी वी हैव डिस्कस दिस मेनी टाइम्स. सो इट्स आंसर विल बी ए. नाउ क्वेश्चन नंबर 63 इज द वैल्यू ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी ऑफ अर्थ is the same on equator and poles, is the least on the poles, is the least on the equator, or D. increases from pole to equator. सो ये सेम टाइप ऑफ, ये आंसर का पार्ट था एक पहले वाले क्वेश्चन में भी. सो वी नो दैट इट इज़ द लीस्ट ऑन द इक्वेटर, बिकॉज जो रेडियस ऑफ द अर्थ है वो बहुत, इट्स द हाइएस्ट एट द इक्वेटर. नाउ द नेक्स्ट क्वेश्चन इज क्वेश्चन नंबर 64. द लॉ ऑफ ग्रेविटेशन गिव्स द ग्रेविटेशनल फोर्स बिटवीन A. the earth and a point of mass only, the earth and the sun only, any body having some mass, and any two charged bodies. तो इसका आंसर भी आई थिंक वी ऑल नो दैट इट्स सी, एनी टू बॉडीज हैविंग सम मास, बिकॉज द ग्रेविटेशनल, द यूनिवर्सल ऑफ ग्रेविटेशन यही है दैट देयर इज अ फोर्स बिटवीन एवरी ऑब्जेक्ट विच हैव सम मास. सो इसमें अर्थ का, सन का या फिर चार्ज का देयर इज नो, जस्ट दे शुड हैव मास. Now the next question is the value of quantity g in the formula for gravitational force. A. depends on the mass of the earth only, depends on the radius of the earth only, depends on both mass and radius of earth, depends neither on the mass nor the radius of earth. So इसमें भी बहुत वो confusing सिर्फ g वाला part है, that it's a capital G, so it will neither depend on the mass of the earth or the radius of the earth, because it is g is always constant. but अगर small g होता then it would have depended on both, then g की वैल्यू चेंज हो जाएगी अगर रेडियस कम या ज़्यादा हो या फिर मास कम या ज़्यादा हो. तो सिर्फ हमें g का ध्यान रखना है, वेदर इट्स कैपिटल और स्मॉल. Then the next question is, two particles are placed at some distance from each other. If keeping the distance between them unchanged, the mass of each of the two particles is doubled. The value of gravitational force between them will become 4 times, as it is directly proportional to the value of gravitation is directly proportional to the mass of the object, so it will become 4 times. In the relation F is equal to gmm by d square, the quantity g, A, depends on the value of g at the place of observation, is used only when the earth is one of the two masses is the greatest on the surface of the earth. D is of the same value irrespective of the place of observation. So correct answer is D, is the same value irrespective of the place of observation, because again the value of capital G will always remain constant. Uska place, object ka mass, anything doesn't matter, it will always remain same in this universe. Then question number 68 is, the gravitational force of attraction between two objects is x, keeping the masses of the object unchanged. If the distance between the objects is halved, then the magnitude of a gravitational force between them will become A, x by 4, B, x by 2, C, 2x, or D, 4x. So as the gravitational force is inversely proportional to the distance between them, between the objects, so the answer will be D, 4x. Question number 69. An apple of mass 100 grams falls from a tree because of gravitational attraction between the earth and the apple. If the magnitude of force exerted by the earth on the apple be F1 and the magnitude of force exerted by the apple on the earth be F2, then A, F1 is very much greater than F2, F2 is very much greater than F1, F1 is only a little greater than F2, F1 and F2 are exactly same. So the correct answer will be F1 and F2 are exactly equal because of the third law of motion, that every object has an equal and opposite reaction. Every force has an equal and opposite reaction. So because जितना मास अर्थ उस एप्पल पे एक्सर्ट करेगा, उतना ही मास एप्पल भी उस अर्थ पे एक्सर्ट करेगा. So F1 and F2 will be exactly equal. So next question is, according to one of the Kepler's law of planetary motion, A, R2 is directly proportional, R square is directly proportional to T cube, B, R is directly proportional to T square, C, R cube is directly proportional to T square, and D, R cube is directly proportional to 1 by T square. So the correct answer is C, R cube is directly proportional to T square. So at the last, thank you all for watching. I hope you all liked this video and it was helpful to you all. I won't be posting the solutions of the second exercise from this book because it contains most of the questions there are of pressure and thrust and buoyancy, which is removed from the syllabus by CBSE. And if you have some suggestions about that किस chapter के solutions or what solution should I post next, then please write that down in the comment section. If you liked the video, don't forget to hit the like button, subscribe my channel and share this video to your friends. It might help them also. Thank you.